Good evening, students. Welcome to PPS online class. This is our second session. In earlier session, we have completed the searching techniques, and in today's session, we'll be focusing on sorting techniques. In yesterday's session, we have seen the searching thing. What is searching? Different techniques to perform the searching. All that we have discussed in earlier session. And in today, we'll be focusing on sorting. Given a list of items, unsorted list of items, how we can sort those items in either ascending order or in descending order. That we're going to discuss in today's session. First, we will understand what you mean by sorting, and we will see a simple approach to perform the sorting. And after that, we'll be discussing uh, three different techniques to perform the sorting. The first one, it is bubble sort, second one insertion sort, and the third one selection sort. It won't be taking much time. I think it will hardly take 40 to 45 minutes before we conclude the session, because every sorting technique, if we take 15 minutes, so all in all, it will take near about 45 minutes before we conclude the session. Okay, without much ado, let's just get into the sorting thing. So the searching, which we have covered earlier, then we have the sorting concept. Okay, so as we all know, sorting, it is another important common application in computer science. As we have seen searching as one of the common application in computer science, sorting is also one of the most common application in computer science. So sorting, it is a kind of process in which the data, whatever list of items they will give to us, we'll try to arrange them uh, in a particular order based on their values. We'll try to arrange them in a particular order. We know that those orders are nothing but arranging them in ascending order or arranging them in descending order. So arranging them in ascending order is nothing but we arrange the items smallest to biggest, isn't it? Small to big. That is nothing but ascending. So descending is something arranging them in uh, decreasing order. Okay, decreasing order in the sense big value will keep first and small value will keep last. Likewise, okay, biggest to smallest, big to small, decreasing order. So ascending, increasing order, small to big, and descending, decreasing order, biggest to small, big to small. Likewise, you can remember. So the application of sorting, we all know that if the data are not arranged in a particular order, that is, if the data is not sorted order, then we face many difficulties. So just imagine the telephone directory, which generally, nowadays these telephone directories, they are not common. We all have mobile phones, and therein the contact numbers we are saving. But in the initial days of telephones, they used to provide a telephone directory. Whenever we take a new connection, they used to provide one telephone directory. In that, all people names with their mobile, with their contact numbers are saved. Okay, are printed. So if that names and mobile numbers or contact numbers, if they are not in the sorted order according to their alphabets, if they are not in sorted order, how difficult it is to check a particular person's name or to identify a particular person's contact details in the telephone directory. We can imagine. Or take the dictionary example. We know that in English dictionary, all the words, English words, they are arranged in alphabetical order, in their alphabetical order. If they are not arranged in that particular order, how difficult it is to get a meaning of a particular word, isn't it? So we can imagine that one also. Okay, all these are some of the applications of sorting. Okay, the advantage of having elements sorted in our day-to-day life, we can easily get that. Okay, so when you go for sorting, it is a combination of two different operations. Okay, generally the sorting thing, it is a combination of two different operations. Here you can see we perform comparison and we perform swap. Okay, sorting, it is a combination of these two operations. When you go for sorting, uh, yeah, it is divided. I mean, it is a combination of these two, compare and swap. Generally, whenever you have something like this, the word combination, let us assume 34, 25. In the list, you have two numbers like this, 34 and 25. So now, if you are arranging them in ascending order. Now we know that 25 must come first and 34 must go next. Okay. So what we do, how we understand, how we analyze in the sense, first we do the comparison between these two numbers. We perform comparison. Okay. So after comparison, we'll come to know that 34 is greater value and 25 is lesser value. So as per the sorting thing, if you are sorting condition, if you are arranging them in ascending order, so 34 should go in this place and 25 should come in this place. So first we performed comparison. Because of that, we came to know their actual positions, isn't it? Their actual positions are 25 should come first and 34 should go next. So after comparison only we'll come to know that positions. And once you know the positions, what we do then? We perform the swapping. I mean, we shift 34 to this location and we shift 25 to this location. This is what swapping. So first comparison, with that we'll come to know which one is greater, which one is lesser. Through comparison only we will come to know. After once you know the which one is greater, which one is lesser, you can swap them so as to make them in proper order. So that is what now. So sorting, it is a combination of two different operations. That is nothing but compare and swap. So that is what in compare, we compare the two values, two different values of the array, and in swapping, based on the comparison done, okay, if they are not in their proper order, we'll try to swap them. Okay, so hope you understand. So this is one simple approach, basic approach to perform the sorting. Given a list of elements, simply what we are doing, we are starting from the beginning of the array and we are comparing every second element with the first element, every next element with the previous element. And if they are not in proper order, we are trying to swap them. Okay, now here, whatever operation we are performing in this particular if else, this is something swapping only. Okay, so here you can see that in this whole thing, it is nothing but swapping. And where we are performing comparison, in the sense, here you can check that one. This is your compare. And if they are not in their proper order, here if they are not in their proper order, after comparison we go for swapping. If they are in their proper order, after comparison we don't do swapping. Let's just understand this thing. If compare result is in order, don't do anything. Compare result is not in order, then go for swapping. So with these two operations only, we make the complete list in its proper sorted order. I'll demonstrate this. I will type this program for you so that you will understand the phenomenon, sorting phenomenon. uh, So here I took one import empty source file and I'm typing my program. So this is the structure. So I'm not using any function, nothing. In my program itself, I'm doing the whole thing. First, I'll take the array with 5 elements and I'll initialize that array to some random values, say some 9, 1, 4, 3, and 5. We all know that they are not in sorted order, neither ascending nor descending. They are not in sorted order. Then I'm taking one temporary variable also just to hold the value temporarily. Then for the outer loop, I'm taking I as 0. I must be less than 5, I plus plus. Then for the inner loop, I will take j, and j must start from I and j must be less than 5, j plus plus, something like this. Then take if, okay, if at all a of j is greater than a of j plus 1, j plus 1, then what we have to mark? It means if they are not in sorted order, go for swapping. Temp equals to a of j, then a of j equals to a of j plus 1, a of j equals to a of j plus 1, then lastly a of j plus 1 equals to temp, a of j plus 1 equals to temp. This is what makes your array in sorted order. After this, just come out of the loops, both the loops, and print the list in the sorted order. Okay, now for printing list, simple thing, start from index 0 and index must be less than 5, I plus plus, then printf, print the whole array, percentile d space, comma, then a of I. That's it. Then come out of the program. So now save it. Program got saved. Compile it. See, it will print the array in sorted order. See, we have taken initially we have taken the elements in random order, not in sorted order, but after applying this logic, okay, this simple logic, compare and swap, this simple logic, how it became all my elements, they became in sorted order. Hope you understood. So this is the very basic approach of performing swapping. Okay, so yeah, there are three different techniques to perform the sorting mechanism. In that, the first one is selection sort, as you can see here. This first approach, selection sort, then bubble sort, then merge sort, heap sort, quick sort, insertion sort. Likewise, many different approaches we have. Okay, selection, bubble, merge, heap, quick, many different approaches we have, insertion, many different approaches we have, but we go with this bubble sort. We'll discuss this bubble sort first, then we'll discuss with the selection sort. We'll go with selection sort, and one more approach which is not printed here, that is insertion sort. We also discuss these three things, insertion, sort. Okay, this is your third approach. So we have to see bubble, in selection, and then the insertion. As per your syllabus also, we need to go with only these three. Here you can see that one. As per your syllabus, see here we need to see the bubble sort, selection sort, insertion sort. These three mechanisms only we need to see. These three sorting mechanisms only we need to see. So we start with bubble sort. Okay, see, whatever list they will give, whatever unsorted list they will give, we do what, mark? We go with, I'll take one empty slide to do the, yeah, we have enough empty slides. So, how we do? So, given a list of items to be sorted, we divide the list into two uh, sublists. Okay, na? Given list will be divided into two sublists. First one we call it as unsorted list, and the next one we call it as sorted list. So our agenda is very simple, ma. Every time we need to pick one item from the unsorted sublist and we need to put in sorted sublist. Every time what we do, we pick one item from unsorted sublist and we put in sorted sublist. So likewise, after performing some, I mean, every time you are picking one unsorted item and keeping in sorted list, we call it as one pass. Okay, na? We call it as one pass. So, given a list of n items, there requires n minus one passes before we make the list, whole list sorted. Okay, just remember this one. I'll make you understand this thing. Pretty simple, straightforward concept. First approach, bubble sort, will do that here. Just see this. So what it will be, how it will be, just take this one. So let us assume they have given the list something like this. uh, List of items 1, 2, 3, 4, 5, and 6. Assume the numbers as 3, 1, 4, 7, 6, 9. Some random numbers they have given. Now our job is to make them in sorted order. Initially, what we do, we divide the list, this given list, into two sublists. Okay, we call one side list as sorted and another side list as unsorted. How we divide means we take the help of an imaginary wall. What we do, we take the help of an imaginary wall. Let us assume it as imaginary wall, and this wall is acting like a divider, okay, like a barrier between the two, between sorted and unsorted. So initially your whole list, complete list, will be in unsorted list only. This whole thing as unsorted list. ఓకేనా అమ్మ, ఈ ఈ అప్రోచ్ కొద్దిగా జాగ్రత్తగా వినండి, బికాస్ ది సేమ్ అప్రోచ్ వి ఫాలో ఇన్ ఆల్ త్రీ. ఓకేనా? సో వి డివైడ్ ది హోల్ లిస్ట్ ఇంటూ టూ sub parts. First part we call it as unsorted because initially in sorted list there is nothing. Sorted list లో ఇనిషియల్ గా ఏముంటుంది, ఏముండదు, because nothing we have sorted so far. So sorted list will be empty and unsorted list will have all the elements. Okay, na? Unsorted list will have all the elements, sorted list will have nothing. And there is a barrier, imaginary wall. We call it as what? Imaginary wall, because it is not real. Okay, we make an imaginary wall between sorted sublist and unsorted sublist. So now how the bubble sort mechanism will work, in the sense bubble sort will always start from the end of the list. E side nunchi start avutundamma, end of the list nunchi start avutundi. Then what we do is we compare the last item, okay, last item with last but one item. ఈ two items ని కంపేర్ చేస్తాం, ఈ two items ని కంపేర్ చేస్తాం. So then after comparison, if you found that left side element is greater, okay na, left side element is greater and right side element is shorter. Left side ante is 6, right side ante ఈ 9 ma. Okay, left side element is greater and right side element is smaller, perform swap. ఓకేనా? వన్స్ అగైన్, లెఫ్ట్ సైడ్ ఎలిమెంట్ ఎప్పుడు ఎలా ఉండాలమ్మా, స్వాప్ పర్ఫామ్ చేయాలి అంటే లెఫ్ట్ సైడ్ ఎలిమెంట్ గ్రేటర్ గా ఉండాలి, రైట్ సైడ్ ఎలిమెంట్ స్మాలర్ గా ఉండాలి. ఆ కేసులోనే మనం స్వాపింగ్ పర్ఫామ్ చేస్తాం. ఇఫ్ ఇట్ ఈస్ నాట్ లైక్ దాట్, డోంట్ డూ ఎనీథింగ్, don't do anything. So in the first pass, what we are doing, we are comparing these two, 6 and 9, and as 6 is smaller and it is left side only, don't perform any swapping, no swapping here. Then what we do, then again 6 will be compared with 7. 6 will be compared with 7. Here you can see 7 is greater, 6 is smaller. So there is a need of swapping. You need to perform swapping here. So 6 కాస్త ఏమవుతుంది, ఇక్కడికి వచ్చేస్తుంది, and 7 ఇక్కడికి వెళ్ళిపోతుందమ్మా. Here you will get 7. Now 6 here, 7 here. Once again, between these two, you perform what we call comparison. 4 and 6. 4 is smaller and on the left side. Don't do anything. Here we performed swapping. Here not performed. Here also not performed. Then again, compare 1 and 4. Compare 1 and 4. 1 is smaller, 4 is greater. Don't do any swapping. Okay. Then again 3 and 1. Lastly 3 and 1. So 3 is greater, 1 is smaller. So 1 should come this side, right side, left side, and 3 should go right side. So here we are performing swapping. So 1 will come here and 3 will go here, like this. So after the sorting, after performing this swapping, comparison swapping, what has happened? The smallest element among the list, the smallest element among the list is automatically bubbled to the beginning of the list. You can see 1 is the smallest element and it came automatically to the beginning of the list. It is something like in the water. In the water, when you pour something, what will happen when you pour additional water? Some bubbles may remain at the bottom. At the initial stage, what will happen? Some bubbles, some air bubbles may remain at the bottom of the water, but after some time what will happen? Those water bubbles automatically comes to the top of the water, isn't it, to mix with outside air to get mixed up with the outside air, those water bubbles, how they will come to the top, what will happen with those air bubbles at the bottom of the water? They automatically comes and mix up with the outside air. So bubbling means they are automatically bubbled to the top of the water. So here also same thing. The smallest element, when you perform this type of technique, the smallest element is automatically bubbling to the top, I mean beginning of the list. So that's the reason we call it as bubble sort, bubbling the smallest element to the beginning of the list, automatically to the beginning of the list. So this is, after this what will happen, ma? After this, if you take the list, how the list will be? Okay, after performing this pass, how the list will be? You can see here, we got 1 here, then we got 3 here, then we got 4 here, then we got 6 here, 7 here, 9 here. Okay, so what has happened? Smallest element automatically bubbled to the top of the list. Then what we do? We shift the imaginary wall one step ahead. One step ahead. So ఈ imaginary wall కాస్త ఇక్కడికి వచ్చేస్తుంది, making the sorted list with one item, sorted list as one item, and unsorted list with one less item. అన్సార్టెడ్ లిస్ట్ లో ఏమైపోయిందమ్మా? వన్ ఐటమ్ లెస్ అయిపోయింది. సార్టెడ్ లిస్ట్ లో వన్ ఐటమ్ ప్లస్ అయిపోయింది. సో దిస్ ఇస్ వాట్ వీ కాల్ పాస్ వన్. We completed first pass. So likewise you need to perform second pass. Second pass లో smallest element automatic గా మళ్ళీ టాప్ beginning of the list కి బబుల్ అయిపోతుంది. Then we shift the wall again. Second pass అయిపోతుంది. Then third pass, fourth pass, fifth pass. Likewise, how many passes? N minus 1 passes we need to perform before the complete list gets sorted. So N is what? Total number of items in the list. Here, how many items we have in the list? 6 items. So how many passes this particular mechanism, this particular list requires before it gets completely sorted, in the sense n minus 1, that is 6 minus 1, which is 5 passes it requires. Okay, 5 passes it requires. So just go to this, and we have one example, one what we call, here we have one example. Do this example. See, in this list, imaginary wall standing at the beginning of the list, and in the sorted list we don't have any item, and in unsorted list the whole list is there. Okay, the whole items are there. Now you can see 56, 32, 8, 4, 45, 78, 23. Likewise, we have the items. Then what they are doing? They are applying the sorting, comparison and swap operation. Sorting apply చేస్తున్నారు, bubble sort mechanism apply చేస్తున్నారు. So 32 will be compared with 56. Here I am applying, just see, 32 will be compared with 56. 32 is smaller, already on the left side, don't apply any swap. Then compare these two, 8 and 32. 8 is smaller, already on the left side, don't swap. Then 45 and 8. 45 and 8. 8 is smaller, on the right side, so we need to perform swapping. Swapping perform చేసిన తర్వాత ఏమవుతుందమ్మా? 45 will come here, 8 will go here. 8 ఇక్కడికి వచ్చేస్తుంది. Okay, then again between 78 and 8. 8 is here now. 78 and 8. 8 is smaller and on the right side. Perform swapping. Swapping perform చేయాలి. So 8 will come here and 78 will go here. 78 ఇక్కడికి వచ్చేస్తుంది. Okay, then again between these two, 8 and 23. 8 and 23. So 8 and 23, which one is smaller? 8 is smaller, so 8 will come here and 23 will go here. So you can see 8, 23, 78, 45, 32, 56. That is what we got here. 8, 23, 78, 45, 32, 56. Then the smallest element after pass 1, smallest element, what has happened? Automatically bubbled to the top of the list. So we moved imaginary wall one step ahead. Okay, now the second pass, we work for second pass. Second pass లో ఎలా వర్క్ చేయాలి? మళ్ళీ ఈ టూ కంపేర్ చేయండి. 32 and 56. 32 smaller, already on the left side, don't perform any swap. Next, 32 and 45 we compare. Yes, there is a need to perform swapping because 32 is smaller, should be on the left. So 32 will come here, 45 will come here. like this. Next, between these two we need to perform comparison. 78 and 32. 32 is smaller, so 32 should go here and 78 should come here. Between 23 and 32. 23 and 32, 23 only smaller, 23 already on the left. Don't compare any item from the unsorted sublist. It is already, from sorted sublist, because it is already sorted. We don't do any comparison. Okay, now we don't consider 8 in this particular pass 2. Okay, so now what has happened? How the list will be: 23, 32, 78, 45, 56. That is what we got: 23, 32, 78, 45, 56. Again, the smallest element is automatically bubbled to the top of the list. So move the imaginary wall one step ahead. So from here, imaginary wall will come here now. And already in the sorted list, we got 2 items, and in unsorted list, 2 items minus. Okay, this is what pass 2. Pass 2. Then we go for pass 3 here. We work for pass 3 here. So 45 and 56. Here there is a need of comparison. Here no comparison we perform. Here again 45 and 56, already 45 smaller on the right side, on the left side, no comparison. Sorry, no swapping. 78 and 45, 45 smaller on the right side, perform swapping. So 45 will come here and 78 will go here. Okay, then here we performed the swap. Lastly, between 45 and 32, 32 is smaller, already on the left side, no swapping. So again 32 bubbled automatically to the beginning of the list. Again you move the imaginary wall one step ahead. So your imaginary wall will come like this. So now we got 3 items in sorted list, 3 items in unsorted list. This is your after pass 3. Now we work for pass 4. Okay, 78 and 56. Between these two, 56 is smaller, should be on the left side. So swapping is required. So 56 will come here, 78 will go here. 78 will come here. Now between 45 and 56, 45 is smaller, already on the left. Don't perform any swapping. So now 45 automatically bubbled to the beginning of the list. Now move the imaginary wall. Imaginary wall will come like this. Now we have only 2 items, 56 and 76. Once again, you perform the comparison between 56 and 78. 56 smaller, already on the left side, no need of any swapping. So now this imaginary wall, this is after 4 passes only they have written. We need to write 5th pass also after pass 5. Okay, after pass 5, what will happen? 8, 23, 32, 45, 56, 78, and your imaginary wall will come here. Okay, likewise we need to perform the sorting. So if there are n items, we need n minus 1 passes. Do remember, n minus 1 passes. N items, n minus 1 passes we need to perform before the list gets sorted. Here you can see we have 6 items, so we performed 5 passes before the complete list gets sorted. Hope you understood this technique. Very easy technique. Then we have, yeah, this overview, I mean this theory related to that only they have given. The sorted sublist, unsorted sublist, imaginary wall, how the items will be bubbled to the top of the list, and how the imaginary wall will move one step ahead in each pass. That only they are discussing here. Okay, hope it is clear for you. We just quickly demonstrate how this operation will work. Bubble sort operation will work. Then we'll go to the next operation, that is selection sort. Okay, so what I'll do here, yeah, I'll take different functions. One is swap function, one is bubble sort function, and other one is printing function. 3 functions తీసుకుంటాను in my consideration, and I'll make you understand this technique very quickly. So first you take the structure of the program. Okay, then here like this. So we take 3 functions, I said now. So one is swap. This will swap the items, given items, int star, because the changes what we are doing to the formal parameters, we want them in actual parameters. That's the reason I have taken call by reference. Int star means call by reference. Next is my bubble sort function. This will take the array and the size. Okay, then I will take uh, print array function. This function, it will simply take the array and print on the output screen. Array తీసుకుంటుంది, array size తీసుకుంటుంది, and it will simply print on the output screen. Now I'm writing swap function. This swap function is common for all the sorting techniques. ఒక్కసారి మీరు నేర్చుకున్నారంటే ఈ ఫంక్షన్ అన్నిటికీ ఏ స్వాపింగ్ టెక్నిక్ అయినా ఇదే అప్లై చేస్తాం మనం. స్వాపింగ్ ఎక్కడ అవసరం వచ్చినా ఇదే అప్లై చేస్తాం. So as simple as it is, we need to take one temporary variable, temp equals to, first you keep x value into it, then inside x value keep the y value, y pointer, and then keep inside the dereferencing y pointer, keep temp. That's it. ఇంతేనమ్మా, ఇది మీ స్వాప్ ఫంక్షన్. దెన్ we perform the print function. Bubble sort last లో రాద్దాం. bubble sort what it will take ma, it will take the list and it will take the size. Okay, code తర్వాత రాస్తాను. Now first I will write the print array because it is also simple and common for all. Print array function, it will also take the list and it will take the size. Okay, it will take the size. In it, simply we take one temporary variable. For loop తీసుకోండి, I equals to 0, I must be less than the size I plus plus. సో అరేలో ఉన్న ఐటమ్స్ ని ప్రింట్ చేస్తున్నామా, ఏదైతే లిస్ట్ మీరు సప్లై చేస్తారో ఆ లిస్ట్ లో ఉన్న ఐటమ్స్ అన్నిటిని ప్రింట్ చేస్తుంది. పర్సెంటైల్ d, then we got the value inside list of I. That's it. Two functions over. Now the bubble sort function, we said now imaginary wall we take. Okay, current is nothing but your imaginary wall, and after each pass we move the imaginary wall. Current equals to 0. Current must be less than the size. Current plus plus. Current is nothing but your imaginary wall. Then internal to imaginary wall, whatever we are finding, that is walk equals to size minus 1, because from the end we need to start the comparison process. Okay, walk must be greater than current, and current minus walk minus minus, walk minus minus. You can see the flowchart also, same thing will be there. If at all your list of walk is lesser than list of walk minus 1, last but one item we are checking, walk minus 1. Okay, then what we have to swap off ఆ two items ని swap చేయాలి, and list of walk and list of walk minus 1. walk minus 1 ని walk తోటి swap చేస్తున్నాం, and addresses we are passing because swap function will take what pointers it will take. Okay, now this is done, and go to your main and write the code. You can pass it and you can check anywhere. If you want to check the code you can pass it and you can check. Initialize the array with some random elements. So I'll keep 64, 34, 25. Okay, some random items I'm keeping in unsorted order. 11, 90, something like this I kept some random elements. So how to get the size of this list I told you this procedure int size equals to size of the whole list divide with size of a particular item, any particular item. Size of list of 0 పెట్టండి, list of 0. This will give the elements, number of elements present in the list. Now you call the bubble sort function, pass the list, pass the size. That's it. Okay, then after sorting, print array. Print array key, again you pass the list and you pass the size. Okay, this will print the whole. So but before calling the print list, some message you have to print. Sorted list ఏ అప్రోచ్ యూస్ చేసి అమ్మా ఏ అప్రోచ్ యూస్ చేస్తున్నా బబుల్ సార్ట్ అప్రోచ్ లో sorted list in bubble sort \n you can keep and beginning also no need. Okay, so go to the end and put the semicolon, save it. Okay, program got saved. Now you can keep here return 0. Okay, program got saved. Just do the compilation. Yeah, there is one exit status, maybe some print array somewhere here. Print array spelling I have written wrongly, that's why I got that error. Now compile. Still undefined reference to print array. Just copy this and paste here and paste down also, because we want the same name in all places. Now compile. Yeah, you can see it got compiled successfully. Then run it. Okay, it is sorted. It has sorted the given list. Whatever list we have taken, it has sorted the given list using bubble sort approach. Hope it is clear, ma. This is how we perform sorting of elements using bubble sort. Okay, then we have selection sort. This is the second technique, ma. Here also we'll do the same thing. We'll divide the list into two sublists. One list we call it as sorted list and the other list we call it as unsorted list. After each pass, one item from the unsorted list will be shifted to sorted sublist. Unsorted sublist నుంచి sorted sublist కి ఒక item shift అవుతుందన్నమాట. Okay, hope it is clear for you. The concept is very simple. If there are 6 elements in your list, n elements in your list, how many passes we need, ma? N minus 1 passes we need before the complete list gets sorted. N elements, n minus 1 passes required before the list gets sorted. Concept is pretty simple, ma. Selection sort. Here also we'll maintain one imaginary wall between the two lists. Sorted list ki unsorted list ki madhyalo em chestam, oka imaginary wall ni maintain chestam. So here you can see this is the given list. This whole thing is your given list. Here we have this whole thing. 1, 2, 3, 4, 5, 6 items we have, some random items. So the concept is pretty simple, ma. Selection sort, what we have to, initially we need to identify the smallest element among the list. List నుంచి complete list నుంచి ఏం చేయాలి, smallest item ని identify చేయాలి. And smallest item, just swap that smallest item with the first item in the list. First item in the unsorted list. Not in the list, ma, unsorted list. Unsorted list లో smallest item ని identify చేయాలి and unsorted list లో smallest item ని unsorted list first item తోటి swap చేయాలి. So this arrow, whatever we marked here, they represent swapping. Okay, nama, they represent swapping. Clear that from this list it is clear that 8 is the smallest element and we are swapping this 8 with 23. Why we are swapping with 23 means because we need to swap this 8 with the first element in the unsorted list. Okay, just swap it. After that what will happen, 8 will come here, 23 will go here. 8 ఇక్కడికి వచ్చేస్తుంది, 23 ఇక్కడికి వెళ్ళిపోతుందమ్మా. చూడండి ఇక్కడ 8 ఫస్ట్ కి వచ్చేసింది, 23 ఇక్కడికి వెళ్ళిపోయింది. సో నౌ ద లిస్ట్ ఇస్ I mean still it is unsorted, but 8, the smallest element is at the beginning of the list. Smallest element ekkada undi, beginning of the list lo undi. So what we do, simply move the imaginary wall one step ahead. Okay, to make the first pass, move the imaginary wall one step ahead. So after moving the imaginary wall one step ahead, what will happen, in your sorted list one item gets entry and from your unsorted list one item will be minused, one item will be decreased, minused. Okay, so here you can see we got 8 in the sorted list and remaining 5 elements in the unsorted list. That is how. This is the completion of first pass. Now in the second pass, once again we need to identify the smallest element in the unsorted list. It is clear that 23 is the smallest element. So shift this 23 to the beginning of the list. Okay, how we do? Simply beginning of the list lo aina item ni smallest item ki madhyalo we need to perform the swapping. Here we are performing the swapping. Then after swapping what will happen, ma? 23 will go here and 78 will come here. 78 ఇక్కడికి వచ్చేస్తుంది, 23 ఇక్కడికి వెళ్ళిపోయింది. So after the swapping, again what we have to, because smallest element in the unsorted list is at the beginning. beginning of the list. So move the imaginary wall one step ahead. So imaginary wall కాస్త మీకు ఎక్కడ ఏమవుతుంది ఇక్కడికి మూవ్ అయిపోతుంది. From here it will come here. See, we got here, and 23 is out the other side of the imaginary wall. 23 is shifted to the other side of the imaginary wall. So now in the sorted list we got 2 items, and in unsorted list one item minus. Only 4 items we have. So one more swap, one more pass. Yeah, we need to identify the smallest element, that is 32. Again, perform the swapping between that 32 smallest element and the first item in the list, that is 45. So what will happen? 32 will go here and 45 will come here. 45 ఇక్కడికి వచ్చేస్తుందమ్మా. 32 ఇక్కడికి వెళ్ళిపోయింది, 45 ఇక్కడికి వచ్చేసింది. So again, 32 smallest element is at the beginning of the list. Move the imaginary wall. Imaginary wall కాస్త ఇక్కడికి వస్తుంది. చూడండి, ఇది సిచ్యువేషన్. After pass 2, this is your situation. Okay, so after pass 3, this is your situation. So because this is pass 1 working, this is pass 2 working, this is pass 3 working. So pass 3 తర్వాత ఇలా ఉంది scenario. 8, 23, 32, 78, 45, 56. Once again, identify the smallest element. We got 45 smallest element. Swap the smallest element with the first element in the list. So 78, 45 swap అవుతాయి. So 45 will come here and 78 will go here. Okay, so now move the imaginary wall one step ahead. Imaginary wall కాస్త ఇక్కడికి వచ్చేస్తుంది. So 45 will be shifted to the other side of the wall. So 8, 23, 32, 45 we got in sorted list, and only 78, 56 in unsorted list. Okay, this is the situation after pass 4. This is the working of pass 4, and this is the situation after pass 4. Now the last pass, fifth pass, we are working out. So what we have to, only 2 items we have, 78 and 56. So again, identify the smallest element, which is 56. Push the smallest element to the, swap the smallest element with the first element in the list. First element in the list is 78. So swap it with 56. So 56 will go here, 78 will come here. So 56 will be here, 78 will be here. Now you can see 56 smallest element is at the beginning of the list. Okay, so again, after shifting, move the imaginary wall one step ahead. So now what will happen? Only one item will be left in the unsorted list. So one item, no need to swap with anything, no need to perform anything. So we consider the entire list as in sorted order. So now you can see 8, 23, 32, 45, 56 and 78, and the list is in sorted order. Okay, hope it is clear, ma. So this is how we perform the selection sort. This is the demonstration, I mean the discussion of how we performed that swapping, sorting using selection sort approach. And this is the pictorial representation, graphical representation using flowcharts. And here we have the code. Again, the code will be same. I will just make the corrections, few corrections in the code. You see what corrections. I don't call this function as BubbleSort anymore, as we are performing selection sort. I need to call it as selection sort. This function, this method, this function name, I'll make it as selection sort. So how it will be? So simply selection sort. The swap function same and print array function same. Reading the list same, and here also simply in place of bubble we need to make selection. Okay, only this thing I have changed, and here instead of bubble, as we are applying selection sort technique, here also you change it as selection. Rest of the code is same. Swap function code same untundi, print array function code kuda same untundi. Only here we need to change. The bubble sort place lo selection sort ostundi, and here we need to apply, I mean the selection sort logic, not the bubble sort logic. So remove the internal code here. Internal code తీసేయండి and apply the selection sort int current walk and smallest, because in every iteration we are identifying the smallest element in the unsorted sublist. So I am starting the approach. Current equals to 0. Current must be less than last. Okay, current must be less than last. That is nothing but the size you can take. Current must be less than size, and current minus minus. Current minus plus plus, sorry, because we are starting from this 0 now. So current plus plus. So initially make your smallest as current, first item only, then apply for, okay, walk equals to current plus 1. Okay, walk must be less than equals to last walk plus plus. Okay, then come down here. If at all your list of walk is less than list of smallest, that is what, wherever you are searching, looking, it should be less than smallest. Okay, if it is so, what we have to make the smallest as walk. Okay, and apply the swapping between the uh, current item and smallest item. After coming out of these loops, apply the swap, invoke the swap between addresses, because call by reference to make the small swapping permanent. SMLST smallest comma ampersand list of current. That's it. Okay, so that's it. ఇన్ని చేంజెస్ మాత్రమే చేయాలి. Just go and check whether it will give the yes, somewhere size it is. Okay, then run it. You can see, okay, some issue. Okay, while invoking here, make it as size -1, because last we are passing, that last is nothing but size -1. Only that error, I guess. Yes, only that error. You can see we got the complete array in the sorted order. Okay, hope it is clear, this approach also. You can pause the video and you can see if there are any issues, if you're not understanding. Whole code I am keeping, this is the main function for selection sort. This is the swap function for selection sort. This is the selection sort function for selection sort. And lastly, the print array function for selection sort. Okay, hopefully it is clear for you. Then we'll see the last technique, insertion sort. Okay, so insertion sort, it is also one of the technique in performing sorting to get the sorted list from the unsorted elements. We use this insertion sort algorithm. So again, here also the same approach. The complete list will be divided into two parts: sorted list, unsorted list, and an imaginary wall will be maintained between sorted and unsorted lists. And after every pass, what will happen? An item will be picked from unsorted list and will be placed in sorted list. Unsorted sublist నుంచి ఒక item ని pick చేస్తాం. Most probably the first item only. First item ని pick చేస్తాం and sorted sublist లో దాన్ని కరెక్ట్ ఆర్డర్ లో ప్లేస్ చేస్తామమ్మా. ఇట్ ఈస్ సంథింగ్ లైక్ ది కార్డ్స్ గేమ్. Okay, while playing cards, what we do, some random cards will be thrown in our end. మన ప్లేస్ లో ఏం చేస్తారు, random cards ని త్రో చేస్తారు. I mean, some, if you are playing 11 cards game, they will throw 11 random cards towards you. Then how you will pick those cards, one by one you pick the cards. After picking each card, what you do, you place the newly picked card in its right position, isn't it? In its right position. ఒకవేళ అది చిన్నదైతే ఫస్ట్ లో ప్లేస్ చేస్తారు, పెద్దదైతే లాస్ట్ లో ప్లేస్ చేస్తారు. Likewise, you arrange the items. So that is how the insertion sort technique will work. Every time we pick one item from the unsorted list and we place it in its correct position in the sorted sublist. One more time I am repeating. Every time we pick one item, generally the first item only. Every time we pick the first item from the unsorted sublist and place it in the sorted sublist in its right position. Places where we place that one, picked item ని ఎక్కడ ప్లేస్ చేస్తామమ్మా, సార్టెడ్ సబ్ లిస్ట్ లో ప్లేస్ చేస్తాం, అండ్ అది కూడా దాని కరెక్ట్ ప్లేస్ లో ప్లేస్ చేస్తాం. I'll make you understand. Here also same thing. If you have n elements in the list, you require n minus 1 passes before the list gets sorted. ఓకే, ఈ త్రీ టెక్నిక్స్ కూడా సేమ్ ఉంటాయమ్మా, ఇలానే వర్క్ అవుతాయి, చాలా సిమిలారిటీస్ ఉంటాయి ఈ త్రీ టెక్నిక్స్ కి మధ్యలో. సో డోంట్ లీవ్ దిస్ సర్చింగ్ సార్టింగ్ యూనిట్ ఫర్ యువర్ ఎగ్జామ్, ఎక్స్టర్నల్ ఎగ్జామ్ ప్రిపరేషన్. ఇట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్ యూనిట్, అండ్ all the three techniques, they are very easy. Two searching techniques, they are dead easy. Three sorting techniques, they are very easy. Okay, so just don't leave these at any cost. And moreover, I told na all LAQ questions only from this unit. వచ్చే ప్రాబబిలిటీ చాలా ఎక్కువ ఉంది. 7 మార్క్స్ 10 మార్క్స్ క్వశ్చన్స్ వచ్చే ఛాన్సెస్ చాలా ఎక్కువ ఉందమ్మా యూనిట్ లో, ఫిఫ్త్ యూనిట్ లో. అండ్ మోర్ ఓవర్ ఫర్ బీటా సెక్షన్, ఐఎమ్ ఆస్కింగ్ యూ టు ప్రాక్టీస్ దిస్ 5 ప్రోగ్రామ్స్: లీనియర్ సెర్చ్ ప్రోగ్రామ్, బైనరీ సెర్చ్ ప్రోగ్రామ్, SelectionSort, InsertionSort, BubbleSort. 5 programs you need to practice in this Tuesday's lab. ఈ ట్యూస్డే ల్యాబ్ లో ఈ 5 ప్రోగ్రామ్స్ ప్రాక్టీస్ చేయాలి కంపల్సరీగా. So here you can see the selection sort approach ma concept. I told na, every time what we do, okay, the complete list will be divided into two portions: sorted list and unsorted list. Every time we pick the first item only ma, first item ni pick chestam, and in the sorted list we identify the right position of that element. అది ఎక్కడికి వస్తుంది, ఏ ఐటమ్ తర్వాత వస్తుంది, ఏ ఐటమ్ ముందు వస్తుందో దాన్ని కరెక్ట్ గా ఐడెంటిఫై చేస్తాం. లెట్ us suppose, I'll make you understand ma here. Suppose you have 3 here, 2 here, sorry, not 2, 3 here, 4 here, 7 here, 9 here. Let us assume you have like this one: 3, 4, 7, 9. And unsorted list లో ఫస్ట్ ఐటమ్ 8 ఉంది మీకు. సో 8 ని పిక్ చేస్తారు. 8 వేర్ ఇట్ హ్యాస్ టు కమ్? 3 కంటే ముందు వస్తుందా 8? నో. 3 and 4 కి మధ్యలో వస్తుందా? నో. 4 and 7 కి మధ్యలో వస్తుందా? నో. 7 and 9 కి మధ్యలో వస్తుందా? ఎస్. సో we place this 8 between 7 and 9. Like that we perform the insertion sort. Every time we pick the starting element from the unsorted list and we place that element in its right position. Here you can see that one. So initially we have how many items ma? 6 items in the unsorted list. Then we picked 23. I mean కంపల్సరీగా ఫస్ట్ ఐటమ్ తర్వాతనే మనం ఇమాజినరీ వాల్ ని ప్లేస్ చేయొచ్చు, బికాస్ ఇనిషియలీ యువర్ అన్సార్టెడ్ లిస్ట్, సార్టెడ్ లిస్ట్ విల్ నాట్ బి ఎంప్టీ మా, సార్టెడ్ లిస్ట్ విల్ హ్యావ్ one item. Okay, and imaginary wall will stand after the first item, and before the second item. Now in the original, this is your original list. To make the sort one, pass one, what we do? We pick the 78. 78 ని పిక్ చేసి ఏం చేస్తాం? ఈ 78 23 కంటే ముందు వస్తుందా, 28 తర్వాత వస్తుందా? 28 తర్వాతనే వస్తుంది. సో we make that 78 after 23. This is how we make 23 78. Then we imaginary wall కాస్త ఇక్కడికి వచ్చేస్తుంది అప్పుడు. ఓకేనా? 45 8 32 56 will remain in the unsorted list. Then again, after pass 1 we pick 45. Where this 45 should go? Between these two. ఈ రెండింటికి మధ్యలో వస్తుందమ్మా 45. So something like this: 23 45 78. Okay, and in unsorted list you will be having 8 32 56. Again you pick the first element from the unsorted list, that is 8. Okay, to make the pass 3. So 8 where it should go? 78 కంటే తర్వాత రాదు, 45 కంటే తర్వాత కూడా రాదు, 23 కంటే తర్వాత కూడా రాదు. Where it will come? It will come before 23. So we place this 8 before 23. Something like this your list will be. Now pick 32. From the unsorted list, pick 32. Where it should go? After 23 it will go ma, ikkada వస్తుంది. So like this. Again 56 pick chestam, last element, and 56 will go after 45 and before 78. So there we place it. So finally your entire list will be in sorted order. So if, as there are 6 elements, how many passes it took ma? 5 passes it took. N elements, n minus 1 pass sets. Okay na? N elements, n minus 1 passes. So after n minus 1, that is 5 passes, your complete list as per selection sort will be in sorted order. Hope you understood. So again we have the demonstration program here. I'll make you understand this one. So quickly I'll shift to the IDE. Just a couple of minutes before we conclude session. Okay, so nothing will change ma here. Uh, as swapping, it is not required here. Okay, swapping it is not required. Nowhere we are performing this swapping, or we can say swapping we write as part of your insertion sort only. So remove this swapping. Okay, remove the what we call here swapping declaration also. Okay, instead of selection sort, we call it as what? Insertion sort now. Okay, insertion sort. Print array will remain same, and here identifying the size is same. While calling the function, make this selection as insertion. Insertion. Okay, and here instead of size minus 1, pass size only. List comma size, sorted list like this only we print. Then instead of selection, call it as insertion. Insertion sort. Down, nothing will change. Print array, nothing will change. In all three sorting techniques, print array will be same only. Here this code will change now. I'll remove this and we'll go with some new code. Okay, just remove this. Okay, so now I'll declare some variables like current, temp and walk. Three variables. Next is for, we need to start from 1 mark current value, not from 0, because first item we leave it in our sorted list. Okay, so then current less than size current plus plus. Okay, then in it make temp as first item, that is list of current first item. Okay, then walk equals to current minus 1. Then while walk is greater than or equals to 0, and list of walk is greater than temp. So as long as these two conditions are true, make list of walk plus 1, okay, equals to list of walk. Okay, next is walk equals to walk minus 1. Okay, then come down after this, list of walk plus 1 equals to 10. Walk plus 1 equals to 10. That's it. Save this code. ఓన్లీ ఈ ఫంక్షన్ డెఫినేషన్ మనం కొద్దిగా జాగ్రత్తగా వర్కౌట్ చేయాలమ్మా. రిమైనింగ్ ఆల్ దే ఆర్ వెరీ ఈజీ. See our list, it is got sorted using not selection sort, but here we need to make it as insertion. Insertion sort technique amma. Last technique, run it. You can see as per insertion sort, the complete list got sorted. Okay, so this is how we perform all the possible techniques: selection, insertion, bubble sort techniques. Hope you understood ma. That's it. So there is some topics still due in your what we call fifth unit. They are the asymptotic notations, that is nothing but basic concepts of order of complexity through example programs. I told na, here we need to discuss the performance analysis that we do in our next class ma. With that we conclude your fifth unit. Okay, thank you very much students.